Welcome to the session on differentiation, differentiating exponentials and logarithms. The objectives for this session are to differentiate exponentials and logarithms. Let's begin by reminding ourselves of derivatives involving exponentials and logarithms. Remember that if y equals e to the power kx, then dy dx equals k times e to the power kx. And if y equals ln of x, then dy dx equals 1 over x. Now for any constant k, ln kx equals ln k plus ln x. Now since ln k is a constant, we have that the derivative of ln kx is also 1 over x. Let's now take a look at an example. We are required to find the derivative of y equals a to the power x. So let's solve this. Now y equals a to the power x implies ln y equals ln a to the power x. We've taken logs or natural logs of both sides. Ln a to the power x equals x times ln a by the laws of logarithms. If we raise both these sides to the exponential e, then we have e to the power ln y equals e to the power x times ln a. And of course, e to the power ln y is equal to y. So if we put k equal to ln a in the standard result for the derivative of e to the power kx, we have that dy dx equals ln a times e to the power x ln a. And rearranging this, or by the laws of logarithms, we have ln a times e to the power ln a to the power x. And of course, e to the power ln a to the power x is simply a to the power x. And this is equal to a to the power x times ln a. And therefore we have this result also. If y equals a to the power x, then dy dx equals a to the power x times ln a. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's take a look at part A first. We are required to find dy dx given that y equals e to the power 5x plus 3 to the power 8x. So let's solve this. We can differentiate term by term, so let's consider the first term, e to the power 5x. If we substitute k equal to 5 in the formula as shown, we have that dy dx of this part of the expression is 5e to the power 5x, as shown. Let's now consider the second term for dy dx. If we plug in a equal to 3 to the power 8, as shown, we have that the second term differentiates to 3 to the power 8x times ln 3 to the power 8. And of course, ln 3 to the power 8 is 8 ln 3. And And so we have our expression for dy dx. Now let's consider part B. We are required to find dy dx given that y equals ln 3x plus ln x to the power 4. So let's solve this. The first term of y now becomes ln 3 plus ln x by the laws of logarithms. And the second term, ln x to the power 4, becomes 4 ln x. So y equals ln 3 plus 5 ln x. If we differentiate this, ln 3 differentiates to 0, and 5 ln x differentiates to 5 times 1 over x. And so dy dx equals 5 over x. Now let's consider part C. We are required to find dy dx given that y equals 5 minus 4 e to the power 4x all over 2e to the power 9x. So let's solve this. We can rewrite the expression for y as 5 over 2 times e to the power minus 9x minus 4 over 2 times e to the power 4x minus 9x. Which is equal to 5 over 2 times e to the power minus 9x minus 2 times e to the power minus 5x. And so we have our expression for y. And so if we differentiate this, we obtain for the first term 5 over 2 times minus 9 e to the power minus 9x, as shown here, and for the second term we obtain minus 2 times minus 5 times e to the power minus 5x. We've simply replaced k by minus 5 in this expression. And so we have this expression for dy dx. So now let's tidy up. And so we have minus 45 over 2 times e to the power minus 9x plus 10 times e to the power minus 5x. This brings us to the end of this session. If you have understood its contents, you should be able to differentiate exponentials and logarithms. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.